Okay. Can you all see the screen and understand the question? This was homework number 7, problem number 4. The question was, y is uniform 1 to 15. X is the number of heads in y flips of a fair coin. What is E of X? See, I think what I want to do is I want to sort of illustrate the question in a little different format. I want to sort of place the question in the arena of conditional distributions. So the idea is the following. So now I know y is uniform 1, and I'm tossing a fair coin y times, right? So the distribution of x, so y is uniform. So that we know y is uniform. So here is method 1. So let me use method 1 towards the answer. Then I'd like to discuss a little bit about the distribution of y. So now, so y is uniform. So what is E of y? E of y, you can think of it in a formula way like I've given in the text, or you can write it down. Sum from k equal to 1 to 15, right? K times probability y equal to k. But y is uniform. So this whole thing is going to be sum from k equal to 1 to 15, k times 1 by 15, right? And that's the same as 1 by 15 into sum of k, that is just 15 into 16 by 2. So 15 cancels off, and I just get 8. Then once you do this, the next step is fairly sort of the only non-trivial step, is that x given y equal to y is distributed as what now? So x is number of heads in y flips, right? So what's the distribution? Can someone on chat say the distribution of x given y equal to y? What will it be? Okay, so distribution of x given y equal to y is I'm flipping a coin y times, right? I'm counting the number of heads. So x is what? X is the number of heads in y flips, right? Of a fair coin. So that means x is binomial with variable y, and so not x given y equal to y is binomial with total number of tosses y, and parameter p is half. Now this will imply that E of x given y equal to y is same as the mean of the binomial, which is just y times half, which is y by 2. The next step you observe is that the relationship you have to use is the fact that E of x is the same as, so maybe I'll copy this in green, maybe it'll be better. E of x is same as E of, and I can think of the inside person as averaging x conditionally on y, right? And then averaging that over all possible values of y. So if you understand the relationship that E of x is just E of x given y, then this will immediately imply that this is just E of, what is E of x given y? E of x given y equal to y is y by 2. So E of x given y is just capital Y by 2. And that will give you in 1/2 times E of y, and that's just 8 by 2, and the answer is 4. So this is one way of doing this problem. That is, use the understanding that this is a key understanding that use the understanding that E of x is just averaging out the conditional expectation of x given a random value, and you average out over 1. So maybe the writing is a little bit off, so maybe I'll just call this in pink, and maybe I'll do in pink. Let's see if that works. So, this very good, very nice. So, and then this is the value y. And I'll keep this in green as before, right? So this is the one in x. Very good. So this may be in red, will be better, but so the outside expectation is in y, and the inside one is in x. So there's one quick way of doing this problem. Now I just want to go and illustrate a little slowly a sort of a more standard way of doing this. So let's just or a more mechanical way, but it gives you a better understanding. So let's do method 2. So what you could do is, if you understand everything, this method 1 is fairly correct. Otherwise, you just go to x. So we know y is we know y is uniform 1 to 15. Very good. And the above calculation you can replicate. You know E of y is 16 by 2, which is just 8. So very good. This much you know. Now I also know x is binomial y, x given y equal to y is binomial y comma n. So let's try and compute from these two information of the conditional distribution of x given y equal to y and the fact that y is uniform, the actual distribution of x. So how does one do that? So here y is between 1 up to 15. So if x given y equal to y is binomial, y comma 1 half, x given y equal to y can take values from 0, 1. X given this, the range of this random variable, that is x given y equal to y, the range is 0, 1 to up to little 1. Now, y ranges from 1 to 15, so this would imply, both these would imply that the range of x is 0, 1 to up to 15. Very good. So now, if a priori I would go and try to compute the chance that x is equal to k for some k in the range of x. So what would you get? You would get probability x equal to k, and you would condition on what y was. So y is equal to y, and y can take the values from 0 to 15, or 1 to 15. Very nice. So, but now I only know conditional probabilities of x equal to k given y equal to 1. So I rewrite this as y equal to 1 to 15, probability of x equal to k conditioned on y equal to y times the probability of y. Very good. So what will I get now? This person right here, x equal to k given y equal to 1. So if k is larger than y, this thing is done, right? This is not you're going to get 0. Right? So one notices that probability x equal to k given y equal to y is equal to 0 for all k larger than 1. Because if you're tossing a coin y times, you will not get more than y heads. So it's only valid for k less than equal to 1, or y is at least k. So it's going to be the sum. So you can replace the sum by the sum from y equal to k to 15 probability x equal to k given y equal to y times the probability of y. So possible. But probability y equal to y is easy. That's just 1 over 15. That's uniform. Probability of x equal to k given y equal to y, is that also easy? That's going to be equal to y equal to k to 15. And then this is just going to be, so you're going to have y tosses and you want k heads. So you have y choose k, right? And then 1/2 to the power of k heads and 1/2 to the power of y minus k. And this would be again the sum from y equal to k to 15. So I would have y choose k, right? And then I would have 1/2 to the power of y, right? And I would have this 1 over 15 would just come out. So in some sense, if you do it like this, then the distribution of y x comes out to be this. This is for k equal to 1 up to. And then you could proceed. This becomes algebraically difficult, but to find the e of x, you could proceed this way. You try and do this as an exercise. If you try and do e of x is summation k equal to 1 to 15, k times probability x equal to k. You try and see as an exercise later on whether this method also will give you 4. Well, so is the idea clear for the two methods? So how to do this problem? On chat, can someone tell me? Anyone on chat on the Zoom? Let me know if the discussion was clear. I'm not sure if you all can hear me. Okay. So I'll leave this problem as it is. I'll come back to it in a second. So now let me proceed to the next problem that I want to discuss. This is from homework 8. So the problem is the following. Let's say you do, just 1 second. Okay, let me now see the problem I want to present. So this is the homework 8 problem number. I think I took. Let me just check the problem. Problem number 2. So homework 8, problem number 2. So here I switch gears. I ask you to find. Let me just put this in maybe in green. Okay. I ask you to find the following. I say I have a x is a continuous random variable. And the PDF is given by f of x is 3x squared, 0 less than x less than 1, and 0 otherwise. That's the PDF, right? So it's outside x, outside 0, 1, the density is 0. And you're asked to find the distribution function of it. So let me try and illustrate sort of the methodology of it. So the answer will be simple to understand once you get answer. But what I want to do is let's just draw f of x first. What f of x looks like. So this x-axis, little f is like here, right? So the function is 0 till 0, right? And then until 1, it climbs up like 3x squared. So it goes up to 3, right? Divided 3, and then it's 0 after that. So these are density functions. These density functions f have several properties, right? That is, the function is non-negative, right? And the function is piecewise continuous, right? So typically, most densities that you will consider will be piecewise continuous. So there's only one point of discontinuity, that's at 1. Right? The only point where the function is discontinuous. This is not relevant for the problem at hand, but as an understanding of density function, you should keep this in mind. The function is non-negative and it's piecewise continuous. And you also have probably observed that the integral from minus infinity f of x dx was equal to integral from 0 to 1 of 3x squared dx, and that's just x cubed by 3 from 0 to 1 times 3, and that just gave you x cubed from 0 to 1, and that just gave you. So these three properties is what I would call as the density function. It's non-negative. Let me write this properly. So f of x is non-negative, and f is piecewise continuous. So these two facts make the fact that f is a density function. Very good. But what's the distribution function? Distribution function is the one that we defined as probability x less than equal to x. So f sub x of x is equal to the chance that x is less than equal to x. So what's that going to be? That's just the minus infinity to x f of y dy. That's the integral. So now what's that going to be? Now little f is 0 outside the interval 0, 1. So that means one clear thing you can do is that if x is less than equal to 0, right, that means the density function is 0 there. So that means f sub x of x is going to be equal to minus infinity to x. X is less than equal to 0. So density is 0 dy, and that's just 0. Very nice. And then if x is between 0 and 1, what will happen now? This means f sub x of x is another case. So it's case 2, let's say. 1, f sub x of x is minus infinity. So I'll write to 0, 0 dy. That part tables. Then plus what I have extra piece here. This is 0 to x, f of y dy, where now since x is between 0 and 1, the density is positive. So I just get, here I'll just write it as 3y squared. Right. So that means this is going to be equal to, this part is 0. So here I'll have 3y squared. So it's y cubed by 3 from 0 to x. And that's just going to be times 3. And that is going to be x cubed minus 0 cubed. And that's just x cubed. Then now, if x is bigger than 1, right? How do you calculate that? So that f sub x of x is on the other side. So the first is you will have this minus infinity to 0, 0 dy. That part will remain. Then plus 0 to 1 of x cubed, x squared, 3x squared dx. That will remain. And plus the rest of the part is from 1 to x. And here it's 0 dy. Right? Function is 0 again. So now that means this is going to be 0. And this is going to be x cubed 3 by 3 from 0 to 1 plus 0. I mean, this is going to be just x cubed from 0 to 1, and that's just 1 cubed minus 0 cubed, and that's just 1. So that means your distribution function f is divided into 3 parts. One is it stays 0 till time 0. It's x cubed from 0 less than x less than 1. And then it's 1 for x bigger than or equal to. That's how the distribution function looks like. Very nice. So now let's just try and graph the distribution function. So how does it look like? So let's try and graph it. So what happens here? You take this function, you put f sub x here, right? And then you have x here on this side, little x here on this side. So function is 0. It starts at 0, right? It stays 0 to 0. At 0, it sort of climbs up like x cubed. So it goes like x cubed. So it reaches the value 1. And then at 1, it stays at 1. So that's how the function looks like. So what are properties we can notice about distribution function? This one. Let's see. Can someone on chat tell me any property they notice of the distribution function? Anybody can say on chat? What do you notice about the function? Any simple property you notice? Okay, let me see. So the first property is that it's always going up, right? It keeps going up. So first property you notice is that f is increasing. Right? So f sub x is increasing, at least it's non-decreasing. It's not, how do you say non-decreasing, or I just leave it as increasing. So give me a second. My pen is giving me news check. That is f sub x of x is less than equal to y, f sub x of y, whenever x is less than equal to y. Right? That's something we observe. The function just keeps going up. We also observe that f sub x is continuous. So as opposed to density function, which is piecewise continuous, your f sub x is continuous. Just keeps that. Other property you notice is that as you go towards minus infinity, f sub x is going to be 0, right? Converges to 0. And as you go towards this side, x goes to infinity, then f sub x of x is converging to 1. And in between, the function is between 0 and 1. So these are important properties of the distribution function that you should observe. Let me just recap. Very good. So when you have your density function like this, you should just identify regions separately and then do the problem. Right. So now let's try and understand these continuous random variables a little bit differently. Let's try and do the last problem. Okay, problem 10, and then we'll close for the day. It's about 4:45. So let me do the last problem. So last problem is what? Last problem says, so number 10 of homework 8. Let's say, okay, let's try this. So the problem says the following. The problem says you have a density function f. It's k times e to the minus x if x is positive and it's 0 otherwise. That's what they're asking you to find what's the probability of the interval 0 to ln 2. So let me do the following. Let me try and do a little different question so you can practice in homework. Let me do a different question. Let me find out for you the probability of, let's say, an interval AB. Like, how does it look? Let me try and do a different question. So first thing you do is, see, now there's this k here. Right? You don't know the k here. It's unknown. So let me answer that question. Let me do it properly. So how do you find the k? First of all, for f to be a PDF, right? We've already seen that f needs to be f of x is non-negative. That's the first thing. And you also need to know that f is piecewise continuous. And the last thing you need to know is that the integral has to be equal to 1. Very cool. So now I have this k here. So from this, what I have, f of x is non-negative will imply that, let me put this in orange again, so that it's clear. Very nice. So first part is from this part right here, right? I immediately get that k has to be non-negative. That's the first. Yes. Now you also know that f is piecewise continuous is automatic, because how does f look like? Let's draw a graph of f. So here f is 0 till 0, right? So f starts at 0, starts 0 till 0. And at 0, it's k. K times e to the minus 1. If 0 is 0 is k. So it starts at k. And then it just comes down. This is how f looks like. So k and this comes down. This is x e to the minus x times k. This value is k. That's what the graph looks like. So this is kind of given to us. This piecewise continuity is okay. It will be verified. It doesn't depend on k, because whatever k value is, it will sort of as long as non-negative, you're on your way. Now, what's the last part tell you? This is the part we have to check now. When will this be equal to 1? For this to be 1, what happens? That means I need integral from minus infinity to infinity f of x dx has to be equal to 1. What does that mean? That means minus infinity to 0, the function is 0. So 0 till here, the whole thing is 0. So 0 dx plus from 0 to infinity, I have k e to the minus x dx, and that has to be equal to 1. Very nice. So what does that imply? That implies this part is 0, k comes out. The antiderivative of e to the minus x is minus e to the minus x from 0 to infinity of is equal to 1. So at infinity, you're going to get 0 because the function is going to go to 0, as you see here. So you're just going to get k times, this is just 0 minus of minus 1 is equal to 1. So this implies that k has to be equal to 1. So now you found out k. So therefore, the actual density function f of x is just e to the minus x when x is positive and 0 otherwise. Very cool. So what do you want? The question I asked you was find the probability of the interval AB. Right? But what's the interval AB going to give you? That means it's the integral from a to b of f of x dx. Right? So now we'll do it case by case. Now, if a is less than b is less than 0, let's say, less than equal to 0. The density function is 0. That means probability of AB is just going to be integral from a to b of 0 dx. And that's just 0. Nothing to be done. Now, what if A and B are both positive? So let's say A is positive, A is negative, and B is positive. Right? Suppose it's like this, in this regime. Then what are you going to get? You're going to get probability of AB is going to be equal to, so you'll have A to 0 of 0 dx, right, plus 0 to B of e to the minus x dx. And what's that going to be? This part is 0, this part is minus e to the minus x, and I have 0 to b. I just get 1 minus e to the minus. Yes. And the last case you consider is when both are on the other side. That is 0 is less than a is less than equal to b. That's the last case. So in this case, what happens? The probability of AB will just be equal to integral from a to b. Both are positive. So density is e to the minus x dx. That is minus e to the minus x whole from a to b. And that's going to be e to the minus a minus e to the minus. Right? So what happens is whenever you give a density function, you may have to compute the k. And once you compute the k, you can compute various probabilities involved. Was it clear? Can someone tell on chat if this calculation was clear? That you found k and then you found the answer. So let's do one conceptual problem and I'll stop for the day. See, suppose I do the following. This is like, again, this is like 5, homework 8. This is like that sort of problem. So here, the idea is the following. Suppose I have x is uniform 0, 1. X is uniform 0. Then let's say I want to find, let's say y is, let's say 5x plus 6. Okay. How do I find the the distribution of y. So let me just do a simple calculation. See, when you want to find the distribution of y, the way one does it is in the form. Let's say I do this calculation. So what you do is you try and understand the distribution function of y. So probability of y less than equal to y for any y enough. You try to understand that first. What's that going to be? That's the same as the chance that 5x plus 6 is less than equal to 1. Now that's the same as x is less than equal to y minus 6 divided by 5. Is the idea clear? That's just an algebra I'm doing. Now, x is uniform 0, 1. So either from the notes or the textbook, you will immediately know that x as PDF, f of x, is just 1 when x is between 0 and 1, 0 otherwise. And the distribution function of f is given by 0 until x less than equal to 0, x when 0 is less than x less than 1, and 0 otherwise. To simply integrate the density function, you will get this. Very good. So now, therefore, this immediately will imply that if y minus 6 by 5 was less than 0, this would imply probability of y less than equal to y is going to be equal to probability of x less than equal to y minus 6 by 5. But y minus 6 by 5 is negative, so that's going to be equal to 0 by the top line. And this part will imply that. Very good. Next thing you know is that if 0 is less than, let me put this in black so it's clear. Next thing you know is that if 0 is less than y minus 6 by 5 is less than 1, that's where the x changes. This will imply probability of y less than equal to y is equal to, again, this person right here. Can duplicate this, get here. And that's going to be equal to what now? From this, it's x. Here, x is just y by 6 by 5. So it's y minus 6 by 5. Very nice. And what's the last range? The last range is when this quantity is bigger than 1. And that's the same as chance that y less than equal to y is equal to, let me copy this. If I duplicate it, I put it right here, I just get that's equal to 1. Okay. And I chose this quantity y minus 6 by 5 because I got the fact that chance of y less than equal to y was same as x less than equal to y minus 6 by 5. So once you have this, how do you find the density function? Okay. Okay. So here our density function now. That means what have I shown in this calculation? That means I've shown you here that the distribution function of f for y is equal to, what is it going to give you? It's going to give you, in this case, it's going to give you 0 if y minus 6 by 5 is less than 0. Is going to give you y minus 6 by 5 if if 0 is less than y minus 6 by 5 is less than 1. And it's going to give you 1 if y minus 6 by 5 is bigger than 1. Okay? Very good. So now let me replace that a little bit. Duplicate it. We'll bring it down. So that is. So let me make all this in black so it's easier for us to sort of, or blue maybe. Now how do I change this? This is the same as y is less than 6 because I multiply both inequalities by 5, I get 1. What is this one? That's the same as, so multiply by 5, I get 0 on this side, I get 5 on that side, I bring the 6. Did I get it correctly? Yeah, that's right. I get 6 on this side is less than y is less than 11. That's what I get. And on this side, I just get y bigger than. And since I'm in a continuous setting, I can put inequalities where I want. So maybe I'll put inequality here, inequality here, inequality here, here. Very good. So that's how distribution function of y looks like. Let me draw the graph of f of y. So how does it look like? It's going to come till 0 till 6. It's going to come till 0 till 6, right? It's 0.6. Then going to go to 11. At 11, the function is 1, right? And in between, the function is a line of slope 1 over 5, right? So this is y by 5 minus 6 by 5. That's what f sub f. This is the line. Right? So it starts at 0, climbs up to 5, climbs up to 1. Now, once you observe this again, you observe the fact that it's continuous and it's increasing. And it's differentiable at almost all points except at b, 6, and 11. It's also differentiable at every point. So therefore, we know that this is the density, this is a distribution function of a continuous random variable. So you look at f sub y. F sub y at y is just the derivative of f. And what's that going to be? That's going to be the derivative of this function. This function derivative is 0 for y less than equal to x. It's a constant function. So it's 0 when y is less than equal to x. And above 11 is also constant function. It's 1. The derivative is 0. So y bigger than 11 is also 0. And what happens in between? In between, the derivative of this is 1 by 5 times 1. And this is a constant at 0. It's going to be 1 by 5. Right? For 6 less than y less than 1. So density function of y looks like, so we'll make this in black perhaps. Looks like what? Looks like 0 till the value 6, 0 after the value 11, and between these guys it's 1 over 5. Very cool. That means what is the distribution density, the name distribution for y? Can someone tell me on chat? If y has PDF, yes, what will be the density function? What is the name of the distribution of y? That's right. So it's the same as, you could think of y as choosing a number uniformly between 6 and 11, right? Because it's giving you 1 over 5. So you think of 1 over 5 as 1 over 11 minus 6. The same thing. That means y is essentially uniform of 6 to 11. Right? So y is just choosing a number between 6 and 11 uniform. That's the distribution of y. So the homework 8 asks you something else, a little bit different from this, but essentially this question will give you the answer. Okay, so I think I'll stop for the day. Thank you very much.